Hello friends, in this video we will learn what is the relation between the coefficient of a polynomial and its zeros. In the last video we found out zero of a linear polynomial is minus b by a, where b is constant and a is coefficient of x. So you see on the board the three polynomials and their general forms: linear, quadratic and cubic. So what does a coefficient means? Coefficient in this polynomial means here linear polynomial it is the value a, and here we have two coefficients: coefficient of x square which is a, coefficient of x which is b, and this is cubic polynomial. So here we have three coefficients. Coefficient of x cube is a, this is constant. It means this is some real number. And coefficient of x square is b, and that of x is c, and this d is constant. This c here is constant, and this b here is constant. For linear polynomial, we have already find out that 0 of the polynomial is equal to minus b by a. So if we have to find out what is the zero of any polynomial, so by looking at this equation itself, we can tell that the zero of this polynomial or linear polynomial will be minus b by a. B is constant, that is 3. A is coefficient of x. So 0 will be minus 3 by 5. Now we have not yet find out what is the relation between these coefficient and 0 of quadratic equation and that of cubic polynomial or cubic equation. So this we will find out in this video. So let us take a quadratic equation. Now we want to find out the zeros of this quadratic equation. So in class 9th we studied to split the middle term and factorize a quadratic polynomial. So we'll do the same here. So this comes out to be, so 0 of the polynomial, that means the value of px will be 0 if x is equal to minus 2. So this term becomes 0, then the whole value will become 0. Or x is equal to 4, then this term will become 0, so the whole value will become 0. So we have find out that minus 2 and 4, these are the two zeros of this polynomial. So now we have found the zeros. The two zeros are minus 2 and 4. So that I have written by symbol alpha is equal to minus 2, that is first zero, beta is equal to 4, that is second zero. So now let us see what happens, what value we find if we add alpha and beta. Minus 2 plus 4, that comes out to be 2. And what if we add, oh sorry, if we multiply the two zeros, this is minus 2 multiplied 4, the value is 8, sorry, it is minus 8. See, we are trying to find out the relation between 0 and the coefficient of the polynomial. So, but can you see that this 2 is same as minus b, the coefficient of x divided by coefficient of x square. So here with the coefficient of x is minus 2 and coefficient of x square is 1. So this is equal to minus 2, which is coefficient of x divided by coefficient of x square, which is 1. This is equal to 2. So the sum of the zeros is equal to minus b by a, that is coefficient of x divided by coefficient of x square. Now let us find out what relation is there in multiplication. If we multiply the two zeros, we get minus 8. But this is equal to c by a, where c is here this c and a is the coefficient of x square. So in this equation, what is c? C is minus 8, and what is a? A is 1. So this is equal to minus 8. So the sum of the zeros alpha plus beta is equal to minus b by a, and multiplication of the zeros is equal to c by a. So this is the relation that we have find out empirically. So now we will try to find out and prove that sum of the zeros is minus b by a and multiplication of zeros is c by a. So for the polynomial ax square plus bx plus c, alpha and say beta, it's 0. So then we can write So we can write this equation now by factoring by the factorization of this polynomial. Now the the method that we studied in class ninth by factorization by splitting the middle term. So we used to find out the factors. So let these be the factors minus alpha and s minus beta, because the alpha and beta, these are the zeros of the polynomial. So from this equation what we get, so we simply multiplied x minus alpha and x minus beta, x into x square, x into minus beta x, minus alpha into x minus alpha x minus alpha into beta is alpha beta. So this is what we finally get, kx square minus k into alpha plus beta x plus k alpha beta. So now if we compare this equation with this one, what we can deduct? So we deduct that a is equal to k and b is equal to minus k alpha plus beta and c is equal to k alpha beta. So we find out, we compare the coefficient a is equal to k, coefficient b is must be equal to minus k alpha plus beta, and coefficient constant c must be equal to k alpha beta. So now let us divide b by a. We get, so we divide b by a, so you get minus k alpha plus beta divided by k. Or this k and k got cancelled because k is a constant. Or we can write this as alpha plus beta So sum of the zeros of the polynomial of quadratic equation or quadratic polynomial is equal to minus b by a. This is the relation that we have found. Now let us multiply c, now let us see what does the multiplication of the product of roots or zero becomes. Here we find it, now you see this zeros in multiplication here. So if I divide c by a, then what do I get? K. So I get c by a is equal to alpha beta, or so this is the relation that we have found between the coefficient of a quadratic equation and zeros of that quadratic equation. Alpha and beta, these are the zeros. The sum of zeros is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square and c is our constant. So similarly we can find out the relationship between the coefficients of a cubic equation and zeros of the cubic equation. And for a cubic equation which has which can have maximum three zeros, namely alpha, beta, gamma, these are the zeros of a cubic equation. So the relationship between the coefficient, I'll write first the equation. So I write the equation. So for this cubic equation, the relation between the zeros and coefficients is as below. The sum of zeros is equal to minus b by a, coefficient of x square divided by coefficient of x cube. And the product of zeros and sum of the product of two zeros taken at a time is c by a. And the product of three zeros is equal to minus d by a. So as we had proved for a quadratic equation, the same way we can prove also for a cubic equation. Now we'll go and solve some of the problems. So let us take a third one, 2.2 exercise, question 1 and third section. It is 6x. So this is the equation and it's a quadratic equation. So here we are asked to find the zeros of the quadratic polynomial and verify the relationship between 0 and the coefficient. So we already know what is the relation, so we need to verify. So this same equation we can put as in the standard form of quadratic equation as like this: ax square plus bx plus 6. Now this equation we will solve by factoring. First we will factorize this equation by splitting the middle term. So we can write 7x as 9x plus 2x. How did I find that I should write 7x as 9x plus 2x? I can write 7x as minus 6x minus 1x minus 4x minus 3x or minus 5x minus 2x. So how did I find that to factorize this quadratic equation I should write 9x and 2x? It is because the constant term here is negative, and we already know that the product of zeros is equal to c by a. So here c is minus 3 and 6 is c is minus 3 and a is 6. So c by a is minus 1 by 2. So if I take a minus 5x and minus 2x, if I write 7x as minus 5x and minus 2x, then their product will be positive one. So I'll get the zeros now, and both zeros will be negative. So the product will not be negative, it will be positive. So I need to find need to split this middle term such that one of the 0 is positive and another 0 is negative. So this becomes 3x plus 1. So these are the factors that we have got of this quadratic equation. So the zeros, so this quadratic equation, now what is the 0? The value of x for which this quadratic equation, the value of quadratic equation becomes 0. It can become 0 if x is minus 1 by 3 or if x is 3 by 2. So minus 1 by 3 and 3 by 2. These are the two zeros of the quadratic equation. If you want, I'll explain you how did I find minus 1 by 3. See, this equation can become 0 if either of these 2x minus 3 or 3x plus 1 is 0. So if 3x plus 1 is equal to 0, that means, so from 3x plus 1, suppose the 0 will, when will that get 0? If this is 0, then the product will come out to be 0. So if 3x plus 1 is equal to the 0, then x is equal to minus 1 by 3. That is 1, 0. We can get 0 of the quadratic equation if 2x minus 3 is also 0. So if 2x minus 3 is equal to 0, that means x is equal to 3 by 2. So this is how we found the two zeros, minus 1 by 3 and 3 by 2. So one part of the equation, question we have solved. Find the zeros of the quadratic polynomial. We have found the zeros. Now we need to verify the relationship between zeros and the coefficient. So here we will write coefficient A what are the coefficient of the equation? A is 6, B minus 7 and C is minus 3. We already know that the standard form of a quadratic equation is this is the standard form of the quadratic equation. So We just need to find out what is the coefficient of x square here. It is 6, so a is 6. What is the coefficient of x? It is minus 7, so b is minus 7. And what is the constant? Constant is minus 3, so c is the constant. Now we will find why we know that the following is the relation between quotient and 0. 0 of any polynomial. What is the relation? It is the sum of 0 is equal to minus p by a, and the product of 0 is equal to c by a. So this we have to verify. So we found these two zeros to be minus 1 by 3 and 3 by 2. Here we found these are the two zeros. So we'll find their sum. Minus 1 by 3 plus 3 by 2. This should be equal to b by a, means minus 7 by 6. So we solve it. Minus, sorry, minus b by a, that is 7 by 6. So what is this? So if we solve the left hand side of this equation, what we get? Just by cross multiplication. It is minus 2 plus 9 divided by 2 into 3. This is equal to 7 by 6, which is equal to your right hand side. So this relation alpha plus beta, that is sum of the zeros is equal to minus b by a, is verified. Now we need to verify the second part of the relationship, that is the product of zeros is equal to c by a. So we'll find the product, minus 1 by 3 into 3 by 2. This should be equal to c by a. So what is c here? Minus 3. And what is a? It is 6. So this should be equal to minus 3 by 6. So is it so? Yes, it is. On left hand side, if we multiply, we get minus 3 by 6 equal to minus 3 by 6. So the relationship between the zeros and coefficient of the polynomial is verified. So now let us solve one more question. So here we are asked to find the quadratic polynomial, and we are given sum and product of its zeros. So let us take this question subsection 2. So we are given root 2 and 1 by 3. These are the what sum of roots. Sum of roots is root 2 and product of root is 1 by 3, and we are required to find the quadratic equation. So first we write what is the general form of the quadratic equation. So if we find these constant a, b and c, then we can identify the quadratic polynomial. So we are already given that sum of root is root 2 and product of roots, or sorry, product of zeros is 1 by 3. And we know the relationship between the sum of zeros and product of zeros. And so we write the relationship. Sorry. And we are given, this is the sum of the zeros is given, then we are given the product of zeros. This we already know that product of zeros is equal to c by a, and this is given to be 1 by 3. So from this we find from this we find minus b is equal to and this the product of zeros give us c is equal to 1 by 3 a. So let us say that if we if the value of a is say 1, then what will be the value of b? B from this will get value of b minus root 2. And if here if a is 1, what will be the value of c? C will be 1 by 3. C is equal to 1 by 3 a. We have assumed that, let us assume that a, the value of a is 1. So c will be 1 by 3. Now we input these values in our standard form of the quadratic equation. This is the standard form of the quadratic equation. So in place of a, we write 1. In place of b, we'll write minus root 2. And in place of c, we'll write 1 by 3. So we have got the quadratic equation from the information provided in question 2, that sum of roots or sum of zeros is root 2 and multiplication or product of zeros is 1 by 3. So one of the quadratic equation which satisfy this condition is x square minus root 2x plus 1 by 3. So with this we come to the end of this chapter on polynomial.